Hey there, sunshines. Today we are going to be talking about adding and subtracting linear expressions. So we're just going to look for combining them. There is not going to be a number answer. I think this is probably the hardest concept for us to grasp in our mind, is that we always want to try and get this number answer. And this one is not going to have a number answer. It will have something plus something, or something minus something, or there might be something plus something plus something. Okay, there might be three. Those are called terms. Those somethings are called terms. So, brace yourself. You're getting into the abstract world of math, and it's going to be a fun ride. Let's go ahead and start off by titling this Adding and Subtracting Linear Expressions, and our essential question is, how can I use algebra tiles to add and subtract algebraic expressions? We're going to focus on these tiles today to give you that concrete evidence on what happens. Okay, yesterday when I was talking to you guys, you were like, why are you highlighting? And maybe this will help give you that understanding of why I was highlighting. And I will really try today to make sure that I'm color coordinating. I don't want to throw you guys off, and I apologize on that last video that I was just picking random colors to highlight. So let's go ahead and define what is a linear expression. It is an algebraic expression in which the exponent of the variable, that means that letter, the letter is 1. Traditionally, you usually use x, but in our book, in our curriculum, we use all kinds of variables. Most of the time, you will see x in the real world. All right, I would write down this key just to help you keep track of what's going on. And let me just double check in my cue that I have those colors. And I do. Let's go ahead and get started. All right, example 1. I'm going to write the algebra tiles for both of our terms to help us keep track. I have a positive x, 1 positive x. I have 3 positive 1s. 1, 2, 3. And then I'm adding to it 2 positive x's. And I'm adding a negative 1. All right, so now my big boxes, these are like terms. They're the same shape. They're like terms. And how many do we have since we're adding them? Since we're adding them, we have 1, 2, 3. 3x. Okay, now I got that done. Got that done. Got those 2 done. Oh, come on, pen. There we go. All right, and now I'm going to combine these are called constants. The little squares are called constants. And I have 3 green and 1 red. So I'm going to go through and cancel out my 0 pairs, because a positive, and a negative. Let me pause my video and be right back. A positive, sorry, my pen's being weird, so this is going to be my chicken scratch right here. A positive and 1 negative make a 0. Okay, all we have left now is that positive 2 right here, this positive 2 right here. So in our algebraic expression, we are going to write down 3x plus, we have those 2 remainder after we add in that 2 pair right there. So plus 2. There we go. All right, number 2, let's go ahead and draw our algebra tiles. We have negative 8z. Negative 8z. Ooh, this is going to take quite a bit of space. Let's get going. Ooh, 1 second. My board is being weird. All right, now I'm going to use my mouse, so work with me here. We have negative 8, 1, 2, 3, 4, 5, 6, 7, 8, and we have positive 4, 1, 2, 3, 4. We have positive 8, 1, oops, these are long rectangular ones, 2, 3, 4, 5, 6, 7, 8, and we have negative 7, small ones. 1, 2, 3, 4, 5, 6, 7. All right, let's go through and combine and cancel our like terms. We have these long rectangular ones and these long rectangular ones. 4, 0 pairs. Positive and negative make a 0. 0, 0, so we don't have any x's. We have 1, 2, 3, 4. 1, 2, 3, 4 ones that cancel out, and all we're left with is negative 3. So after we combine our algebraic expression, we get negative 3. All right, now let's look at number 3, and let's see what we have. Again, using algebra tiles just so we get that concrete. We have a 4 with 1, 2, 3, 4. We have a negative n, so I need 1 negative. Make sure you're keeping track of signs. This is an easy mistake I see. And then we have two sets of negative 5. 1, 2, 3, 4, 5. Positive 3. 1, 2, 3. Two sets of them. That's what that 2 means right there. 1, 2, 3, 4, 5. And we have 1, 2, 3. Okay, now let's go ahead and combine our like terms. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 green little squares. So plus 10. And now I have nothing I can cancel out here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 x's. And they're negative. Ooh, I should have made those all red so you guys knew that those were negative. Negative 11x. There we go. Number 4. Let's go ahead and do number 4. We have half of w minus 6. Half of w minus 6. That's what this half stands for in front. So what's half of a w? That is a little half. I'm going to put a half in there. This one's not nice to do with algebra squares. And you should be saying, how are we going to show that? Because we should use algebra. I'll use algebra on this one for our example. We will distribute a half to w and minus 6. What's a half times w? A half w. Okay. What's a half times negative 6 is negative 3 plus 1/4 times w is 1/4 w. And 1/4 plus times positive 12, 1/4 times positive 12 is plus 3. Because 1/4 times 12 over 1 is 12 divided by 4. Remember, you multiply across, and that's 3. All right, now we're going to identify those like terms. So we have a positive 1/2 w, and we have a positive 1/4 w. 1/2 plus 1/4. 1/2 plus 1/4. Got to multiply by 2, multiply by 2. 2/4 plus 1/2, 1/4, sorry, is 3/4. So now we have 3/4 w. Then we have a negative 3 plus 3. They cancel out, and we are left with 3/4 w. That's exactly what we did over here with algebra tiles. All of this. All right, let's practice our last 2 examples using algebra, not the algebra tiles. It does get a little bit more messy when we're talking about finding the difference, that subtraction in between them. So let's use algebra. Okay, we have m minus 3. Those parentheses didn't really mean anything for this problem because there's nothing to distribute. Okay. We have a minus a negative m, so we do have this minus sign that needs to be distributed. So negative times negative is positive. Negative times positive is negative. And now those parentheses don't mean anything. Okay, identify our like terms. M plus m, positive m plus positive m is 2m. Minus 3 minus 12 is negative 15. and we combine it. Not looking for a number answer, remember, just looking for them simplified. All right, this one does have parentheses right here, and so we are going to have to distribute. Sorry, my board. Come on, board. All right, back to me using the mouse. Okay, so we're going to distribute this -2 with multiplication. So this is going to say -2c plus, and then -2 times positive 2.5 is negative. Let's do our little multiplication. 2.5 times 2. 5 times 2 is 10. 2 times 2 is 4, plus 1 is 5. 1 decimal place. And so, -5. Now we do have a -5. This says -5 because that's minus. -5 times 1.2, -5. Ooh, that was horrible. All right, -5 times 1.2. 1.2 times -5. 2 times 5 is 10. 5 times 1 is 5 plus 6. 1 decimal place, so minus 6c. Minus 6c. Minus negative times positive is negative. 5 times 4 is 20. Now we're going to combine our like terms. 2c, -2c. -6c is -8c. -5, -20. Minus 25. Remember, no number answers. You're trying to just get it by itself. Simplify, not get it by itself. Simplify. All right, go ahead and try these on your own problems. When you're ready to check your answers, please resume. Here's what you should have gotten. I should see 1 algebra tiles and or you should be highlighting. I should see that kind of work on your notes, okay? Algebra tiles or highlighters, okay? Go ahead and answer the essential question and take that checkpoint. I hope you guys have a good night. I'm sorry for how long this video is. My little pad is not working that well. I hope you guys have a good night. Bye, guys.